Hello, this video is to showcase our automated pill dispenser for our EGME 456 Mechatronics final project. My name is Christian Hernandez and my team members are Alexander Garcia and Davis Tran. This presentation will cover the following topics: team organization and general contributions by each member, the general functions of our machine, the dispensing system, the stock check system, our bill of materials including costs outside of our kit, and finally, our results and any lessons learned from our project. Alex Garcia's contributions included being the main programmer for our dispensing system. His role included programming the servos based on how I assembled the circuit and ensuring each servo is activated at its time. Davis programmed and assembled the stock check system. He also fabricated the machine's housing out of wood purchased from Home Depot and 3D printed our funnels and pill reservoir. My contributions include assembling the circuit for the LCD screen on both systems and using the real-time clock module, or RTC for short, to display the date and time. Our pill dispenser is composed of two systems, dispensing and stock check. These two systems would incorporate an LCD screen and an Arduino Uno, both supplied from our class kits. Our dispensing system is composed of two servos, which both are powered by a 9-volt battery. The reason why we went with this approach is so that the servos can overcome the internal friction once activated. We found through testing that 5 volts was not sufficient to make the servo move the full 90 degrees. This system is also composed of two push buttons. These buttons will function so that the user can update the time and date. This is useful for users who jump between time zones and those who undergo daylight savings. The LCD is able to display the time thanks to our RTC module. Since the RTC module has a battery attached to it, if the system were to accidentally shut down, the correct time would still be displayed once the system reboots. Our ideal dispensing system will function as shown. The user would change the date and time with the push buttons if needed. Once the clock hits the dispensing time set in our code, the servo will rotate about 90 degrees to drop the pill, and then return to its original position. The buzzer will then go off for approximately 2 seconds, alerting the user that it is time to take the pill. This will then go on a continuous loop. Now, let's see this in action. And then one of them is what, 119?
You're recording, by the way.
I know.
Ready?
Mm-hmm. Now, let us look at our stock check system. This system is composed of another LCD screen that informs the user if there is a shortage of pills in its tubing, with the help of the LEDs and the photoresistors. Our ideal system will have the two LEDs shine continuously. The photoresistors will then take a reading based on its surrounding light. If there is little to no light due to the pills blocking the LEDs, we will get a good stock message. If the photoresistor gets a high reading, the LCD will notify the user which reservoir they will need to refill. If the user refills the reservoir, they will then receive a good stock message. Now, let us again see this in action. Our machine is primarily made up of parts within our class kits. The wood purchased from Home Depot and the 3D printing filament are the only components outside of our kits. In total, our team had to spend a total of $50 for the creation of this project. Overall, I'll put the dispenser function as intended. There are moments where the ambient lighting and lighting from the neighboring LEDs can alter the readings from the photoresistors. This would give a false alarm that the user is low on medication. Some improvements to overcome this is to make the housing fully enclosed so that ambient lighting will not alter the readings. Another is to divide each reservoir so that the neighboring LEDs will not contribute to the false readings. We may need to paint the interior black so that there is better light absorption from the LEDs. That concludes our presentation. On behalf of myself and my teammates, we would like to thank you for watching this presentation.